In this module, we are going to study trigonometric functions and also signs of trigonometric functions. We will see in this module that how signs of different trigonometric functions change as we move from one quadrant to another. We will discuss the domain and range of trigonometric functions. Using domain and range, we will plot their graphs and check their periodicity. Trigonometric functions. Consider a unit circle with the center at origin of the coordinate axis. Let PAB be any point on the circle with angle AOP equal to x radians. That is, length of an arc AP is equal to x units. You can see this in figure 1. We define cos x as A and sin x as B. Since triangle OMP is a right triangle, we have OM square plus MP square equals OP square, or A square plus B square is equal to 1. Thus, for every point on a unit circle, we have A square plus B square is equal to 1, or which can also be stated as cos square x plus sin square x is equal to 1. Since one complete revolution subtends an angle of 2 pi radian at the center of the circle, therefore, angle AOB is pi by 2, angle AOC is pi, and angle AOD is 3 pi by 2. All angles which are integral multiples of pi by 2 are called quadrantal angles. Now, the coordinates of the points A, B, C and D are respectively 1, 0, 0, 1, minus 1, 0 and 0, minus 1. Therefore, for quadrantal angles, we have cos of 0 degree is 1, sin of 0 degree is equal to 0, cos of pi by 2 is equal to 0, sin of pi by 2 equals to 1, cos of 3 pi by 2 equals 0, sin of 3 pi by 2 is equal to minus 1, cos of pi is equal to minus 1, sin of pi is equal to 0, cos of 2 pi is 1 and sin of 2 pi is 0. Now, if we take one complete revolution from the point P, we again come back to the same point P. Thus, we observe that if x increases or decreases by an integral multiple of 2 pi, the values of sine and cosine function do not change. Thus, sine of 2n pi plus x is equal to sin x, where n belongs to integers, and cos of 2n pi plus x is equal to cos of x, again n is belonging to integers. Further, we see that sine of x is equal to 0 if x is equal to 0, plus minus pi, plus minus 2 pi, plus minus 3 pi onwards. That is, when x is an integral multiple of pi, then sine of x will be 0. And cos of x is 0 if x is equal to plus minus pi by 2, plus minus 3 pi by 2, that is, cos x vanishes when x is an odd multiple of pi by 2. Thus, sin x equals to 0 implies x is equal to n pi, where n is an integer, and cos x is equal to 0 implies x is equal to 2n plus 1 pi by 2, where n is an integer. Now, let us see how do we get the values of cot and tan. Cot of x is equal to cos x upon sin x when x is not equal to n pi, where n is any integers, and tan of x is equal to sin x upon cos of x when x is not equal to 2n plus 1 pi by 2, where n is an integer. We will now take some examples to understand the concepts which we have done. In example 1, we have to find the value of sine of 19 pi by 3. Now, sine 19 pi by 3 can be written as sine of 6 pi plus pi by 3. 6 pi completes 3 revolutions. So, sine of 6 pi plus pi by 3 is equal to sine of pi by 3, which is further equal to 3 pi by 2. So, we can say that value of sine 19 pi by 3 is equal to root 3 by 2. In example 2, we will find out the value of cos of 1470 degree. Now, 1470 degree can be written as 4 into 360 degree plus 30 degrees. So, 4 into 360 degree completes 4 revolutions. Therefore, cos of 1470 degree is same as cos of 30 degree, which is equal to root 3 by 2. Now, we define other trigonometric functions in terms of sine and cosine functions. Cosec of x is 1 upon sin x. Condition: x should not be equal to n pi, where n is any integers. Sec of x is equal to 1 upon cos x. Again, x should not be equal to 2n plus 1 pi by 2, where n is any integers. In example 3, we will try to find out the value of sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4. We will prove here that this is equal to minus 1 by 2. We have sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4, which can be written as sin pi by 6 the whole square plus cos pi by 3 the whole square minus tan pi by 4 the whole square. Substituting by their values, this is equal to 1 by 2 the whole square plus 1 by 2 the whole square minus 1 square. On simplification, which becomes 1 by 4 plus 1 by 4 minus 1, which is equal to half minus 1 equals to minus 1 by 2. Now, we are going to see signs of trigonometric functions. Observe the given figure. Let PAB be a point on the unit circle with the center at origin such that angle AOP is equal to x. If angle AOQ is minus x, then coordinates of the point Q will be A minus B. Therefore, cos of minus x can be written as cos of x, and sine of minus x is minus times sine of x. Since for every point P, A, B on the unit circle, minus 1 is less than equal to A is less than equal to 1, and minus 1 is less than equal to B is less than equal to 1. We have minus 1 is less than equal to cos x is less than equal to 1, and minus 1 is less than equal to sin x is less than equal to 1 for all x. We have learned in previous classes that in the first quadrant, that is when x lies between 0 to pi by 2, A and B are both positive. In the second quadrant, that is pi by 2 to pi, A is negative and B is positive. In the third quadrant, that is when x lies between pi to 3 pi by 2, A and B both are negative. And in the fourth quadrant, which is 3 pi by 2 to 2 pi, A is positive and B is negative. Therefore, sin x is positive for all values of x lying between 0 and pi, and is negative for all values of x lying between pi to 2 pi. Similarly, cos x is positive when x lies between 0 to pi by 2, negative when x lies between pi by 2 to 3 pi by 2, and also positive for all values of x between 3 pi by 2 to 2 pi. Likewise, we can find the signs of other trigonometric functions in different quadrants. They are as follows. Sine function is positive in first quadrant, positive in second quadrant, but negative in third and fourth quadrant. Cos x is positive in the first quadrant, negative in second and third quadrant, and again positive in the fourth quadrant. Tan x is positive in the first quadrant, negative in the second quadrant, positive in the third quadrant, and again negative in the fourth quadrant. Cot of x is positive in the first quadrant, negative in the second quadrant, positive in the third quadrant, and negative in the fourth quadrant. Sec x is positive in first quadrant, negative in second and third quadrant, and again positive in the fourth quadrant. Whereas cosec x is positive in first and second quadrant and is negative in third and fourth quadrant. Further, we have following results which can be derived. We state them here without the proofs. These are sin of pi by 2 minus theta is equal to cos theta, cos of pi by 2 minus theta is equal to sin theta, sin of pi by 2 plus theta is equal to cos theta, cos of pi by 2 plus theta is minus sin theta. Now, sin of pi minus theta is sin theta, cos of pi minus theta is minus cos theta, sin of pi plus theta is equal to minus sin theta, cos of pi plus theta is minus cos theta, sin of minus theta is minus sin theta, and cos of minus theta is cos theta only. We can easily derive similar results for other trigonometric functions. In example 4, we will find out the value of tan of 480 degrees. We have tan of 480 degrees, which can be written as tan of 360 plus 120 degree, which is equal to tan of 120 degree only. Now, 120 can further be expressed as 90 plus 30. So, tan of 120 degree is tan of 90 plus 30. Due to 90 degree, tan changes to cot, and this is in the second quadrant. So, tan of 90 plus 30 degree is equal to minus times cot of 30 degree, which is equal to minus root 3. In example 5, we will find out the value of tan of 19 pi by 3. Tan 19 pi by 3 can be written as tan of 6 pi plus pi by 3. 6 pi means complete 3 revolutions. So, this is same as tan of pi by 3, which in turn is equal to root 3. In example 6, we will find the value of cot of 570 degree. Now, cot of 570 degree can be written as cot of 360 plus 210, which is same as cot of 210 degrees. Now, 210 can be written as 180 degree plus 30 degree. Therefore, cot of 210 degree is same as cot of 180 plus 30 degree, which is equal to cot of 30 degree which takes the value as root 3. In example 7, we will find the value of sine of minus 11 pi by 3. Sine of minus 11 pi by 3 is equals to minus times sine of 11 pi by 3, because sine of minus theta is minus times sine theta. Therefore, minus sine 11 pi by 3 can be written as minus sine of 4 pi minus pi by 3, which is equal to minus times sine of minus pi by 3, which in turn becomes sine of pi by 3, and value of sine of pi by 3 is root 3 by 2. Therefore, sine of minus 11 pi by 3 is equal to root 3 by 2. In example 8, we have to prove that cos of 90 plus theta sec of minus theta tan of 180 minus theta divided by sec of 360 minus theta sine of 180 plus theta cot of 90 minus theta is equal to minus 1. We have left hand side is equal to cos of 90 plus theta sec of minus theta tan of 180 minus theta divided by sec of 360 minus theta sine of 180 plus theta cot of 90 minus theta, which is equal to minus sine theta into sec theta into minus tan theta divided by sec theta minus sine theta tan theta, which on cancellation gives the value as minus 1, which is the right hand side. In example 9, we have to prove that cos of 3 pi by 2 plus x into cos of 2 pi plus x, the whole thing multiplied by cot of 3 pi by 2 minus x plus cot of 2 pi plus x is equal to 1. We have cos of 3 pi by 2 plus x into cos of 2 pi plus x, the whole thing multiplied by cot of 3 pi by 2 minus x plus cot of 2 pi plus x. 3 pi by 2 can further be expressed as pi plus pi by 2. So, this expression can be written as cos of pi plus pi by 2 plus x, cos of x whole thing multiplied to cot of pi plus pi by 2 minus x plus cot of x. So, on considering the quadrants, this becomes minus cos of pi by 2 plus x, cos of x whole thing multiplied to cot of pi by 2 minus x plus cot of x, which is equal to sin x into cos x multiplied by tan x plus cot x. Now, tan x and cot x can further be expressed as sin x upon cos x plus cos x upon sin x. On taking the LCM, the entire expression becomes sin x into cos x, the whole thing multiplied by sin square x plus cos square x upon sin x into cos x. Value of sin square x plus cos square x is equal to 1. So, our left hand side is sin x into cos x into 1 upon sin x into cos x. On cancelling sin x and cos x, we get the left hand side as 1, which is equal to our right hand side. In example 10, we will prove that cos of pi plus x cos of minus x divided by sin of pi minus x into cos of pi by 2 plus x is equal to cot square x. Left hand side is cos of pi plus x cos of minus x divided by sin of pi minus x cos of pi by 2 plus x, which is equal to minus cos of x into cos of x divided by sin of x into minus times sin of x. So, numerator is minus cos square x and denominator is minus sin square x. which on division becomes cot square x, which is same as our right hand side. In this module, we have seen how sin x vanishes when x is an integral multiple of pi and cos x vanishes when x is an odd multiple of pi by 2. Also, how signs of trigonometric functions change in various quadrants was also discussed in this module.